This is a pufferfish. Puffed up, bristling with spikes, frozen in place like a balloon that grew teeth. It looks like a mistake, a slow, round fish that decided to turn itself into a pincushion. But that shape is hiding something. Under the spikes is a body built unlike almost any other fish in the sea. So let's open one up. What is actually inside a pufferfish? Start with the obvious part, the spines. When people first see them, they guess the same thing. Those have to be bones. Ribs, maybe, pushing out through the skin. It's a fair guess. Ribs can grow into strange shapes. A turtle's ribs spread out wide and fuse together to build its shell. So why couldn't a pufferfish grow its ribs into spikes? To find out, we need something to compare it to. Here is an ordinary fish, a piranha skeleton. Look at the ribs. Thin, curved bones, and every one of them connects to the spine, to the row of vertebrae running down the back. That's how ribs work in almost every fish. They anchor to the backbone. Now, hold that picture in your head and look at a pufferfish. Here's a pufferfish skeleton, and draped over it is a sheet of preserved skin. Watch what happens when you lift the skin away. It comes right off. It isn't fused to the skeleton at all. It's a separate layer, like peeling off a jacket. Now, turn that skin over. There they are, the spines. Rows of them, layered across the inside of the skin. That's the answer to the first question. The spines are not attached to the vertebrae. They are not ribs. They are not part of the skeleton at all. They live in the skin. The old, simple explanation calls them modified scales. Picture a shiny fish. Imagine one scale growing long and sharp, and you get a spike. But developmental biologists looked closer, and the story got stranger. These skin spines aren't ordinary scales. They grow their own way, in patches across the body. And they're built by an ancient set of genes, the same genetic toolkit that vertebrates use to grow skin structures like hair and feathers. So deep down, a pufferfish spine has more in common with a strand of hair than with a rib. Now, go back to that skeleton, because the spines are only the first surprise. Compare it to a normal fish, and something is missing. A lot is missing. Pufferfish and their relatives have stripped-down skeletons. An average fish in this group carries around 300 bones. Many other fish carry more than 500. No true ribs, a reduced, simplified frame. Even the pelvic fins are gone. For most fish, that would be a disaster. Fewer bones, smaller fins, slower swimming. But the pufferfish traded speed away for something else. And you only see what when it decides to puff. Here is the trick the whole body is built around. When a pufferfish is threatened, it doesn't race away. It can't, not fast. Instead, it gulps. It pulls water into its mouth and pumps it backward again and again, forcing it down into the stomach. Not the part that digests food, a special elastic stomach built to stretch. With no ribs in the way, and with specially modified gill muscles doing the pumping, the body has room to expand. The stomach balloons. The skin pulls tight. The fish swells to 3 or 4 times its normal size. And as the skin stretches, the spines that were lying flat stand up. That's the whole point of them. When the skin goes taut, the spines reinforce it, especially around the belly, and turn a soft, slow fish into a spiked ball no predator wants in its mouth. The stomach can do this over and over. Its walls are packed with collagen fibers arranged to stretch out and snap back, a balloon that doesn't wear out. For a long time, people assumed a puffed-up fish was simply holding its breath. It turns out that's too simple. Studies on pufferfish show they can still pull oxygen from the water while inflated. But it isn't free. Puffing up, and even getting ready to puff, is hard work. A pufferfish's oxygen use can jump to around 5 times its resting level. So this is not a casual party trick. It's an emergency button. Expensive, exhausting, and saved for the moment a predator gets too close. Now look at the front of the fish, at the mouth. The family name, tetrodotoxin, means 4 teeth. And that's almost exactly what you see. 4 teeth, fused into a hard beak. 2 on top, 2 on the bottom. It looks like a bird's beak stuck on a fish's face, and it's a tool. The pufferfish uses it to crunch through the shells of crabs, clams, and snails, food most fish can't touch. The beak even keeps growing, so all that crushing never wears it down to nothing. There's one more thing inside, and you can't see it at all. Many pufferfish are poisonous. Stored in their organs is a chemical called tetrodotoxin. By some measures, it's more than 1,000 times more toxic than cyanide. It works by jamming the body's nerve signals. It blocks the tiny channels that let nerves talk to muscles, and the muscles stop answering, including the muscles you breathe with. There is no antidote. But here's the key detail. This is not venom. A pufferfish doesn't inject it or spit it, it just carries it, concentrated in the liver, the skin, the intestines, and the ovaries. It's a warning built into the body itself. Cooking doesn't destroy it, freezing doesn't destroy it. The poison just sits there, quietly making this fish the last meal a predator ever takes. So look at that spiky balloon one more time. Almost nothing about it is a joke. The spikes are not bones. They are skin spines, grown with a genetic toolkit also used for structures like hair and feathers. The skeleton is stripped down on purpose. The stomach is a pump. The mouth is a shell-cracking beak. And the whole thing is quietly loaded with one of the strongest poisons in the ocean. A pufferfish isn't a fish that got unlucky and turned round. It's a fish that gave up speed and built a fortress instead. And that fortress starts with what's inside. If you want more animals hiding a design you'd never guess, stick around.